Okay, hello.
Hi.
Hi, can you hear me?
Yes.
Cool, awesome. So we'll be spending like 45 minutes on coding problem and last 10-15 minutes for feedback. So before we start, can you tell me like do you have hard stop after 1 hour or it's okay to go a little over?
I have a hard stop after 1 hour.
So you have, okay,
Mm.
sure. So I will try to keep it as close to 1 hour as possible. Yeah.
Okay.
Cool. So this is the first question. You have a root of a binary tree, and you have to return the in-order traversal of its node.
Okay. Um, so in order traversal, that would be the order where the left nodes are returned, then um, let's see. So if I have, it's going to be hard to draw a tree, but um, when I'm thinking of in order, I'm thinking of going down the left subtree and then returning that left leaf, then returning like its parent, and then returning the right node. Is that correct?
So what would be in-order traversal for this binary tree?
5, 4, 6.
Correct.
Okay. And and then we have a binary tree, and that means that each node has at most two children. Um, okay, yeah. So if I let's see. Um, okay, I'm gonna. Like, do I need to choose my language?
Yeah.
Okay, so given the root of a binary tree, return the in-order traversal of its nodes values. So I need to write a function, and I'm given the root of the tree, and like in this example, given the root of the tree before, and I need to um, basically return the in-order traversal. So I'm thinking that I want to take a recursive approach. So if my tree, I guess if my tree, if I'm given a root if I'm giving none as a root, then I just basically return none. Yet if the root of this tree is valid, but it doesn't have any children, I'll just return the root's value. So, okay, those are my two base cases, or cases that I think of immediately. And I know that I want to return the left subtree or the left leaf node, like where I want. Node, parent node, and then the right node. So let me think. 4, 5. So if root,
How would you define a tree node? Binary tree node?
how do I define a what node?
Binary tree node?
I don't think I understand the question. Like,
How would you represent a tree node? Like will it be a class? Like how does the tree node class looks like?
oh, that's not given. I assume it'd be some sort, like a node,
Mm-hmm.
with a value and the value left and right.
Okay.
Yes, left and right pointers.
Okay.
Okay. So I know that I want to get down here, so I start at the root node and then I check to see if the root node has like a left subtree or like a left node, and if it does, then I would like repeat the check if it has a left or right subtree, but if it doesn't, then I can return this value and then it would backtrack and it should visit this node again and return it, and then it should visit this node and return it. So how do I code that? In order, I'm given the root. Okay. So I'm given the root of a tree and I want to return the in-order traversal of its nodes values. Well, I have these two checks in the beginning. If root is none, then return none. And if that's not the case, if root dot left equals none and root dot right equals none, then I just return root dot value. Those are like my base cases. Now I need to think about I need to think about the case where I have a left and right child. And so let's see. Think about it up here. If root has left subtree last child, then I need to basically call this function again, like like a recursive call. It would be like in order root and or whoops, return in order root. Okay. Now I'm hitting a bit of a difficulty because I know that it can return the value of the get to a leaf node. I know it will return the value, but I'm struggling to figure out how to get the parent node, I guess, printed out before that right subtree node.
You don't need to print out. You need to return a list. So the output is expected as a list of this.
I don't need to return the value. I just need to.
You don't need to
Oh,
print. You need to return a list. You need to create a list and return it.
okay. Okay. Well, now that changes things. I need a minute to think.
Sure.
I know that if I'm doing, I can't do recursive because I need to add on to the list instead of adding or creating a new list each time. So I need to figure out the structure of the structure of this code.
Can't you append the list? Like list which you got from left subtree, the list which you got from right subtree.
I'm sorry, could you repeat that?
Can't you just append the list? Like let's say for example, if you get a list from left
List
subtree.
from left.
I think there is a echo. I don't know why. So if there is a list from subtree and if there is a list from right subtree, you can append them.
Yes, I can do that.
Mm-hmm. So your
Okay.
base case is already taken care of. You just need to worry about recursing it. Like let's say like so, you call a left side and you get a left list, right?
All right.
Right? And how will you append them?
I'll just do left list plus right list.
But you also need to append the value of this current node in between, right?
Yes. Okay. So, okay, if I look at the code that I have now, I have a result list which is
Mm-hmm.
empty, and I'm starting at the root node. If the root node is none, then I return none. Or I guess if it's none, I want to return an empty list instead.
Mm-hmm.
If the root, if it's just the root, then I just need to return the root value. Um,
Mm. Mm-hmm.
it's not I don't think that's completely right
Mm.
because
Mm-hmm.
if I'm calling on this like recursively,
Mm-hmm.
uh, it's not adding to the list. It's just returning a a list with a single item in it.
Mm-hmm.
So okay, so I need to edit result and then return result. There you go. And let's see.
So if you are creating result, then do you want to return the result or
I don't want to return the result because that would cause
right?
the function to basically end.
Right.
So okay, so now I have this case out here. Okay, and then these two, once we get to this line, it's going to call order in order, and it's going to return, or it's going to have this as the parameter, and this can either
Mm-hmm.
be none because the next node really doesn't exist on this side, or it can actually be another node, valid node. So,
You already checked if even if you go to the none, your base
mhm,
case will be taking care of it, right?
right, correct. So here, I'm thinking you at the end of this, I do. mm, Okay, I know I need to add the left list plus the current node plus the right list. So I know I need to do this. Is that? I don't think that would work. Okay, because I wanted just to add. I wanted to make. Oh, sorry. I wanted to make it a list value. But I don't think that works in Python. Oh, okay. So let's
Do you
see if
really
I.
require the case this condition line at line number 29?
What about the condition at 29? Do
Do
I?
you do you need it? Because like even if you go to the none node, you are taken care of, right?
Oh. oh mm, but okay. Hmm. If my okay, I'm a little confused because if I pass a root like a none node
Mm-hmm.
in, then it's gonna
Mm-hmm.
return empty list.
Right.
But this is the case. But line 29 is a case where the root is valid.
Right. Let's say like you pass 5 to line number 29, right? And if you don't have this condition, you will end up calling none and none for left and right. And you will get two empty lists and just append 5 in it, right? So this,
Oh, it
mhm,
basically does the same. It does the same thing. Oh, okay.
yeah,
I see. It just takes an extra step to do the same thing. Okay, so if that
right.
is the case, then this is not necessary because it just repeats the same.
Mm, right. Can you remove it? Yeah. Cool. Awesome. I think yeah, this should work. Let's move to the second question. What would be the complexity of your code?
The complexity of this here.
Mm-hmm. Yeah.
Um, oops. So it's traversing the tree, and it's a binary tree. And it's going to visit each node once. Would it be O of, for the time complexity, O of log n, and then
Mm-hmm.
the space complexity would be O
Why
of,
log n? Why would be the log n? What
for
is
the
log?
time,
What is log? What is n there?
n is the number of nodes,
Mm-hmm. How it would be log n?
because it's a binary tree, so um, it's basically looking at half of the nodes each time, I believe.
Mm-hmm. But you would be visiting each node at least once, right?
Right. Um, yes, that's true. Uh, I will be honest and say I'm not well versed in trees. This is probably one of the few tree questions I've actually practiced on.
Mm-hmm.
I know that with binary search or binary trees, that when you traverse them, I guess that the time complexity is O of n or O of log n,
Yeah.
and I know
Like
that this
actually
have.
it would be order of n because you would be visiting every node, right?
Oh, okay, yeah, it'd be O of n. Okay, I see.
Understood. Cool. Let's move to the second question. Like I have pasted the second question at the top.
Okay. You are given a large integer represented as an integer array of digits, where each digit is the ith digit of the integer. The digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. Okay. Most significant to least significant in left to right order. The large integer does not contain. Okay. Increment the large 1 and return the resulting array of digits. Okay, so if I look at the first example, I have 1, 2, 3, and I just want to add 1 to it. The array represents the integer 123. Okay. Okay. Yeah, so I'm just basically given an integer and I need to add 1 to it and return the resulting array of digits. Okay, so let's see. Okay, and I'm always going to increment the digit by 1. I don't have to increment it by 2 or 3.
No, you always increment by one.
Okay, so let's see. So this is just basically simple addition. I am going to add 1 to the ones place each time, and there's the case where I don't have to carry a digit over, and there's a case where I do have to carry a digit over. So let's see. Okay, if I'm looking at the first case, one with 1, 2, and 3, I can go over to the ones place, get the value from there, and add 1 to it, and then basically replace the 3 and have the new digit included in there. But if I look at this third example here, I just can't simply replace the I can't just replace that element because I would need to have 2 different elements in the output array. So my first thought is that I can to make it a bit easier, I can reverse the array, and then I know once I reverse the array, I'll have the ones place in the very front, and so I can add 1 to the ones place. Then I have like the 2 cases I have to think about: need to carry and don't need to carry. After I consider all of those cases, then I can reverse the array and then return it. So if I need to carry, I can have that being I can indicate that with a variable. If this variable is true, then I do the addition. I'm sorry. If I need to carry, then I'll indicate that with a variable, like a true or false variable. And then if I need to carry, I know that the ones place digit is 9, and that 9 needs to turn to a 0. So I would replace the 9 with a 0, and then I would increment to the next digits place. In the case of me starting with the ones place, I'd go on to the tens place, and then I would just add 1 there. But also, I still need to check if I need to carry, because if I have a number like 1,999, then I'm going to carry more than once. So, yeah. And then if I don't need to carry, then I just replace or just simply add 1 to the digit. Okay. Is this approach clear?
Yeah, I understand it. How it will work on this case? What would...
Oh, so if this is the example I have, the first thing I would do is reverse it to this number, and then second step, you would add 1 to the ones place. And so I need to carry in this case because I'm working with a 9. And so, like I said, I would this 9 would be, I would have a carry variable. It would evaluate to true. This 9 would become a 0, and then I would iterate to the next spot right here. And so the carry variable would be would still be true. So I would change this to a 0 as well, and then when I get to this next place, after like the evaluations are done and my carry variable, what do you call it? When my carry variable evaluates to false, all I'll need to do is simply add 1 to this place. It'd be a 9. And then I just return this reversed again.
Cool. I think, yeah, what would be the time complexity of this?
Of this, so reversing the array itself would be a time complexity of O of n. And then this would be a loop. And that would be O of n as well. And then this reversing the array, again, is O of n. But when I reverse the array, those are like outside of this loop. So the overall time complexity of this looks like it's going to be O of n.
Mm-hmm. Can we avoid reversing array?
Can we avoid reversing the array? Yes. If you don't reverse the array, you can just iterate to the end of the list, add 1, and then you can continue with the same loop, but you would have to go backwards.
Mm-hmm.
Yes, I think it's possible to do it without reversing the array.
Okay.
So which one should I code first?
Without reversing?
Okay. So I want to just add 1 to the ones place. I need to get to the very last digit. So I can do that with for I in range length array -1 steps that goes gonna go backwards 1. So okay. So starting at the end of the list, I'm just gonna copy this down lower so I can see it. Okay, so I want to add 1 to the ones place. So I need to see whether or not I need to carry. And I do this by if the array at this position is equal to 9. If it is, I'm going to have a variable. Initialize it to false. If the array at this digit is equal to 9, then I know I need to carry. So my carry needs to be set to true. And then, let's see. While carry is set to true. Let's see. I need to update this digit to a 0. Okay. If the array at this digit is equal to 9, I need to carry. And so after I set carry to true, the array at this particular digit turns into a 0, and I need to increment the next digit by 1 only if I don't have to carry. Okay. This is okay. This is gonna get messy, I guess, before it gets clean.
Do you
So,
need this while loop? Like you already iterating backward, right? If it is not going to get carry, then you will just break the for loop.
okay, I'm trying to do a lot of work in one loop. Okay, I see. Okay. So, okay, I'm going backwards. If I need to carry, that means that the digit I'm at is equal to 9. And then I could just change this digit to 0, else
Mm-hmm.
array at this variable equals.
Mm-hmm. I think yeah. Do you mm-hmm.
Um, okay.
Do you want to test it?
Okay, yes, I'll do that. I'll just return the array at the end. Okay,
Mm-hmm.
so I'm working with 1, 2, and 3. I'm going
Mm-hmm.
to have for I in range. Okay, so the length of this array is 3. It's going to start at 2 until it gets up to -1. So, oh, you just wanted to actually like print it out.
Let's try that.
Okay.
You end up incrementing everything.
Right. Okay. That is not what we want. We only want to increment it by 1. Okay, so where am I going wrong here? So I want to start at the end of the list. And if I need to carry, then I carry.
Do you need to break the loop in else part where you increment it?
Yes, I know I need to break the loop. I'm just trying to understand where. Because like in
Mm-hmm.
the case that I just only have to carry once, I think this is fine, and I can um, increment,
Break.
or
Okay.
I can just break. But
Mm-hmm.
I'm curious about like when I have 2 nines in my number.
Interesting. Yeah.
Yeah. So like I think this could work for here. Like
Mm-hmm.
it works for this case.
Mm-hmm.
Now I'm just curious to see about this because right now I'm only editing my carry value once, but I might need to like fix it. Um,
Do you mean something like this?
yes.
Do you want to try running for this? Mm. Yeah, it did. It worked properly.
Okay. Um, just
I
want to
think
try
it,
one more case. I'm
mhm.
sorry.
I think it will fail for all nines, like if everything is nine.
Okay. Okay. I see. Okay. I was worried that it wouldn't register all the nines, but I see now.
But like for all nines, I think it will fail.
Okay.
Mm.
Well, that is another case I need to consider. It's like whenever I need to add a digit.
Right.
Um, okay. Interesting. Okay. Let's see. I know I need to add a digit whenever I have to, whenever my carry variable is still true on the
Mm-hmm.
like most significant digit.
Right.
So let's see. Because right now I'm just replacing the digits. I need to have some sort of condition, or write some sort of condition that will tell me whether or not I need to add a digit, and then I can just insert.
Right.
Um, right. So let's. There's. Hmm. I feel like there's like subcases with this one too. You have 999. You can also have something like 1000. No, that'd be fine. Okay. Okay, I see now. Okay, so
Or you can even count if everything is 9, right? You can have counters like if everything is 9, then flip and went to it.
yeah. So because like outside of the, I would do this outside of the loop because, well, no, because if I do it outside of the loop at the very end, then none of the nines would be there. There'd be all zeros. So
Yeah, so you already
then,
having this condition here, you can just increment the count.
okay, I guess I do it at the beginning. So if uh, oops, if the array dot count of nine is equal to the length of the array. Mm, it should be. I'm thinking I should indicate that with a variable and then like look at that variable at the very end. So at the beginning of the
Mm-hmm.
loop,
Mm-hmm.
or right before the loop, I would count the number of nines, and if the number of nines is equal to the length of the array, I need to set something to true. So like I guess um, add a digit, gotta be set to true. But I would, and then once I get at the end of this for loop, I can say if add a digit is true, then I can
Prepend.
do the, oh yeah, I can add the array insert at 0, I think it's 1.
Mm-hmm.
Is it, I think the arrays, I think the method is insert at the beginning position 1.
Mm-hmm.
Okay, so if I run this,
Awesome.
then it works perfectly. Okay,
Does it work for the previous cases? Cool. Awesome.
yeah,
Yeah.
so the time complexity of this,
Mm-hmm.
uh, of this, of this function. Let's see. So I have some if statements, which is constant. I have some initializations, constant. I have this loop here. Okay. So the bottleneck of this function is this for loop here, and this for loop is only iterating an array backwards. So
Mm-hmm.
all the elements in the array I would consider that to be n. So I think the time complexity of this would be O of n.
Mm-hmm. Cool. Yeah, that's correct. Um, so yeah, do you want to try one another problem or you have hard stop?
I kind of have a hard stop. Like I don't think I'll be able to answer the next question in the next 15
Okay.
minutes. So
Okay.
I just want to like I guess talk about feedback and
Sure.
whatnot, what I can do better. I mean, I know you have an
Sure.
evaluation, you write it down, but is there anything that we can talk about now?
Yeah, so I think like I like that you for the first problem you, even though you were new to the binary trees, you identified that it would be a recursive approach. So you communicated it correctly that it would be a recursive approach to solve the problem, right? Then you came up with like base cases, like when the tree is none or root has no children, like those cases, right?
Right.
And you came up with the appropriate structure for the node, and you converted your base cases into code easily. I think like there was redundant case, like only root equals to null was required base case, right? And that should be suffice. So other case was not required, right? Maybe but with the practice you will understand this, like why what cases don't are redundant. So my suggestion would be like to practice a bit more on recursion and a binary tree.
Okay.
I have shared a link at the top for the binary tree as a resource.
Okay.
Yeah. So my session would like to go through the basics of it. I think like you mentioned the time complexity would be log n, whereas like the time complexity was n, which was a
Mhm.
big difference. But yeah, as you mentioned, like you are new to binary trees, so yeah, it is expected. But yeah, in the second question, like I really like the way you approach. You clarified that it will always be increment by one, or will it differ by one or two or three, things like that. You clearly identified the case where you need to either carry or you don't need to carry, right?
Mhm.
And you shared a step-by-step approach. I really understood like what you are trying to think, but I think like the carry was not used. This variable carry was never used. So that was again a redundant code in your code. If you see like
Okay.
carry is never used. It's initialized, but it's never used. So yeah, the expectation would be like even at least if you are using it, but after the code, you are done with the code, you can identify what is your redundant code and remove it. Like this carry was never used.
Right. Okay. Yeah.
I,
This served as the carry variable,
right,
basically.
right.
Okay.
Yeah, I think like initially you missed breaking from the loop and end up like incrementing everything, but you were able to debug it and figure it out what is the issue and debug it, so that's all good. I think you also handled the edge case of like all being nines correctly. So yeah, I think like in the second problem, yeah, like you did really well. And based on this like overall interview, it would have been higher call. Like I would have in like let's say for example, this would have been a phone screen. I would have asked given a recommendation to move to the next step and call for the on-site. But yeah, my suggestion would be like to practice a bit more on binary trees and recursion so that those glitches goes away.
Okay.
Cool. Do you
Awesome.
have
Thank
any
you.
question for me?
Um. Let's see. Like, I guess when you were on my side
Hmm.
interviewing, uh, what did you do to prepare in like, I guess specifically like while you were in college, how did you prepare for interviews while handling schoolwork at the same time?
Yeah, so I kept a target of like having solving at least two, three problems a day. That was I like two was the target for me. I just not go into coding. I just don't try to get the solution coded. So I use lead code. So basically, I used to write down the approach in plain English language initially, so that like I get a practice of articulating my thoughts, and then analyze the complexity of my solution, and then start coding the problem. And I will try to come up with my own test cases so that like solution gets accepted in a first go. Like my target was not to solve multiple problems with a good speed. My target was like to get solution accepted in a first go. So like I will try to force myself to think about test cases before submitting the code, so
Okay.
that like I get in a habit of identifying the issues in my code.
Okay. And my next question is, since a lot of the interviews are virtual,
Hmm.
how do you like try to visualize or show your interviewer what you're thinking? Because it's kind of hard to,
Hmm.
like I was thinking, I didn't know how to draw a key or draw a tree in this
Hmm.
coding environment. So like, is there any tips on like how you can show your interviewer what you're thinking, even if it's virtual?
Yeah, so you can use the XKLE draw. So you can say that I can maybe I can share my screen, and you can use XKLE draw to draw things for the discussion point, and then you can stop sharing your screen once you share your thoughts.
Okay, gotcha. Okay, I'll keep that in mind. Okay,
When are
yeah.
your interviews?
I have one coming up in January.
Oh my, you still have time. Okay.
Yeah, yeah. So that
Awesome.
I'm still applying, but yeah. And that was
Cool.
all the
Yeah.
questions.
Okay, understood. Cool. Awesome. Then I will give you your 8 minutes back. Yeah, all the best for your upcoming interviews. My suggestion would be to practice a bit more on binary trees and recursion, and maybe schedule one more interview to make sure
Okay.
that you go through it. Yeah.
Okay. Yeah. Of course. Yeah. Thank you so much for your time today. This was really
Yeah.
helpful.
Thank you. I think you need to write a feedback after this. So yeah, please do
Yeah.
that.
Okay. All right.
Yeah,
Have a great
bye.
rest of your day.
You too. Bye.